Yeah.
It's easier.
So this one here, 23. Let's look at number 24. Same way. Let me open the whiteboard for this one. Okay. So it's going to take a few steps. So I'm going to do 24. Let me go to the whiteboard. So
I first also had an issue with it, but I think I solved it.
Oh, okay. So let's go over to the whiteboard. All right, so this will be, let me just arrange my windows here. So this was from 8.4. And the question we're doing is 24, but you're doing 23 for the homework. So let's say the question is to add, subtract, or simplify. Simply simplify. Simplify. That's say 5 radical 8 plus 3 radical 72 minus 3.
What is it?
50.
It's 23?
24.
Oh, it's 24.
That's 24, yeah.
Okay.
Oh, you'll do 23 for the homework. Okay, so basically we want to simplify the whole thing. So we have addition and subtraction, as we said before. Unless we have the same number here, the radicand, and the same index, which is an invisible 2 here. The index is 2, 2, and 2. We can't add. But if we can't add and subtract right away, we're going to try to simplify all these radicals as much as possible. Then maybe we may end up with similar radicals to add and subtract. Let's start with radical 8. Do we know the radical of 8? Is it a whole number?
So it's 4 and 2, basically.
It's not a perfect radical, right? It's not like radical 9, which is radical 4, which is 2. It does exist, but it's a decimal. If we plug this in the calculator, probably, what is it? Close to
it's 4 and 2?
Close to 3. 2 times something, 2 times 5, 2 times 6. So if you can't find the radical of this, then you're going to try to split the 8. You're going to try to break it down into 2 numbers. One of them might be or might have a perfect root. For example, the 8 we can turn into what? 2 numbers that multiply to 8?
4. No.
4 and?
Yeah.
And 2.
And 2. Which one of these has a perfect radical or root?
2.
4, so it's 2.
4.
Oh, yeah, 4.
So we're going to do 5 times radical 4 times radical 2. So when you have a multiplication inside a radical, you can split that into 2 different radicals. So this turns into what? Radical 4 is, or the square root of 4 is?
2.
2. And this 2 stays under the radical.
The same.
And we can't break it down. It's as simple as you can get because it does exist. It's a decimal. I believe it's 1.41 or something like that. But we better leave it as a radical, not as a decimal. Then we do the same thing for the other one. So this is completely simplified. We can multiply these two. 5 times 2, 10. Then we're going to repeat the same process with these other 2 radicals and see if we can end up with the same radical, for example, 2. If we end up with the same radical, then we will be able to add and subtract all of them. Let's repeat the same process with 3 radical 72. Do you know the radical of 72? You do know the radical of, for example, 49, 81. But since we don't know the radical of 72, it's not a whole number, it's a decimal. Let's find 2 numbers that multiply to 72.
19.
One of which might have a perfect radical.
Oh.
36 times 2.
So 72, we can get that in different ways. So there are multiple ways to get 72. Give me any 2 numbers that multiply to 72. Give me any 2 numbers that multiply to 72.
Yes, 8 times 9.
8 times 9.
I mean, yeah, sorry.
Anything else?
Yeah, 32 times 2 in order to get the radical 2.
32 times 2, no.
36, I said.
36. What else? Any
4
other
times
combination?
18.
4 times 18. That's correct. Any other combinations? Okay. 12 times what?
You said 48 times 18 is equal to
Not
72?
18 times 4. What did you say again, Amber? I'm sorry.
4 times 18.
Sorry, 4 times 18. I don't know why I wrote all that stuff.
You scare me.
I'm fasting, you know. It started to impact me. What is it again? 4 times 18, right? What else? There's probably another one. 12 times what? 12 times what is 72?
Times 6.
Times 6. And of course, 72 times 1. I believe we listed all of them. Did we miss anything? What about 3 times something?
Yeah. No.
3 times. Okay, that's pretty good. Now, if you look at all these combinations that multiply to 72, which one of them has
24.
which one
Sorry.
of them has the largest possible perfect root?
36 times 2.
That's right. So 36 is the highest perfect number we can get the perfect radical from. Not 9. We can
Are
hear
you
you.
telling that 36 is the perfect radical? Can you explain that?
Yes. So
Sorry, guys, but I just don't understand.
yeah, that's okay. So here we have 8 and 9, right? 9 has a perfect radical, a perfect root, but 36 is even better because it has even a larger radical. What is the radical of 36? Or the square root of 36?
6.
9.
It's 6, right? It's better than 3. The square root of 9 is 3. The square root of 4 is
2.
2. But these don't have perfect square roots, so we're going to cross those out. 12 and 6. None of them has a perfect root. Same thing with 72 and 1. 4 and 2. This one has 4. This one has 36 and 9. But this one seems to be the best option because it gives you the highest perfect radical possible among all these combinations. Okay, so we're going to choose this over all the other combinations. So we're going to say radical. Instead of 72, we're going to turn this into 36.
Wait, so Professor, you got to go to the highest number for the radical?
That's right. We take the highest one.
All right. Can you write that?
Okay, so here we have 2.
Mm-hmm.
Wait, Nan, what do you do with this radical?
Plus 3 plus 6. Radical 6.
We're going to turn this into 2 radicals, the 36 by itself, and
2.
The 2. Why? Because we want to simplify this. It will be 3 times, what is the square root of 36 again?
6.
6 times radical 2.
2.
Then we do the same thing with this one.
So if the radical for 36 is both are the same numbers, you just write the one number? You don't double write 6 times 6, you just write 6, right?
Yeah, so that's, yes, the square root of 36 is 6. Okay.
Okay.
Then we're going to do the same thing with 50. Unfortunately, 50, it doesn't have a whole number as a radical. If it was 49, it would have been perfect. Radical of 49.
Why? Because 25 times 25 is not, no.
We can do 25 times 2.
That's right. So since we don't know the radical of 50, it's close to 49, but it's not exactly 49, so it's very close to it. But since we don't know it, so we're going to split the 50 into 2 numbers, just like here. One of those numbers should have a perfect radical. So the numbers we're going to use here are?
Of 25?
Times 2.
And 2. What other combinations that multiply to 50?
10 and 5.
50 times 1.
If you have any background noise or music playing in the back, please turn that off or at least mute your mic because we can hear you here.
50 is it's been like I'm at 50 everywhere almost in my homework, and I don't think that there's anything which like we have just to leave it like this, right?
So 50 is 25 times 2. Okay, but also 10 times 5. We can't use 10 times 5, right? Because this is not a perfect root. This
I
is not a
forgot
perfect
about
root.
24.
So
Okay, I did it wrong then.
We're going to say radical 25 times radical 2 minus 3. Now, what is the radical of 25? Radical of 25 is 5.
5.
This is a multiplication.
5 times 5, 25.
That's right. And radical 2, it's not. It doesn't have a perfect root. It's a decimal, so we leave it like that. Let's simplify all these now.
Oh, we got 2s.
Okay. So we're going to multiply all these. So that's 10
So it will be 13 radical 2
plus.
Oh.
Plus what?
18.
18.
18. Put radical 2
Radical 2.
minus 15 radical 2.
That's right. Minus 15 from here. Radical 2.
Boom.
Good. Can we now add and subtract all these radicals?
Yes,
Yes, because?
because they all have the same radical, which is 2.
Right. By the way, we're going to get disconnected very soon. So rejoin the meeting right away. Let's do this quickly before we disconnect. So we're going to add all these first.
So that's 28.
That's 28, radical 2. What else?
Minus 15.
Radical 2, which is 28.
13.
13 radical.
Radical 2.
Yay, we made it on time. We made it on time.
Go, Amber.
Okay, we're going to get disconnected very soon. Again, rejoin with the same link, the same password.